What's up, Algebra 2? We're going to look at section 6.1, real roots and radicals. The actual title to this section was just roots and radicals, but I added the word real in there because we're not going to have any i's. We're going to stay within the real numbers, so I thought I'd note that. And I now regret making that underline. It looks terrible. It's not straight. Oh well. Should I restart? Now, let's go ahead. Real roots and radicals, section 6.1. So let's look at something that we've done a lot of. We've done a lot of something like this. I said the square root of 9, and then that equals 3. And you've been doing that for ages. And so let's step it up a little bit. We also have cube roots, right? I could say the cube root of 8, and that was going to be 2. So the cube root, let me write that in there. I forgot to. Now, what the square root means is actually should be a 2 there. It's one of those things that we do in math where if we don't write a number, it means something. If we don't put a number here, that means that there's a 2 there. So 3 multiplied by itself, or 3 to the second power, gives you 9. And here, 2 to the third power gives you 8. So this is like an inverse operation for an exponent. One thing that I want to note real quick before we move on is that this means the same thing. Well, here, let me put the 2 there so that we can see it. And this is called the index. That number in there is called the index. Okay, and I could write this as an exponent. I could say 9 to the 1/2 power and 8 to the 1/3 power. The index is really just the denominator in the exponent. So the index goes right there. Now, you might not believe this. Let's go ahead and try it just to see and make sure that this actually works. 9 to the 1/2 power, something crazy, right? Who would ever think to do that? 9 to the 1/2 power. Whoops. Okay, that does give me 3, so that is correct. That's the square root of 9. And 8 to the 1/3 power, and I have to remember to put that in parentheses. Whoops. Choo. Okay, 8 to the 1/3 power is 2. So this is correct. That's 3 and that's 2. And we're going to use a fact like that in just a little bit. So I wanted to put it up there right now. A little note about these, the plural of indexes, indices. So a little note about these indices. If you have an even index and an even index, we've usually had an even index. The square root is an even index. And when we've taken square roots, we've had plus or minus. We've had those two solutions. You know, plus or minus, plus or minus, plus or minus, plus or minus. Oh, but only if the number is positive. Okay, I don't want to write the word positive, so I'll just say greater than 0. So when I had an even index, there were two solutions if it was greater than 0. You know, we can't take a square root of a negative number. We had to use an I to do that, but I said at the beginning of this lesson, no I's, just real roots. So forget that. Okay, and no solution if the number was negative. And of course, I'm leaving out when it equals 0, but 0 multiplied to any number of times still gives you 0, so that's kind of a trivial case. So I'll ignore that for now. Let's look at an odd index. Okay, this would be like the third root. 3 is an odd number. It would be like the 5th root, 7th root. If I put a number there that's odd, well, that's what will happen here. There is one solution. Okay, so let's look at an example of that, kind of like here. The square root of 9 could have been positive or negative 3. We usually assume it's the positive one, but just for, you know, overall, we could say it's positive or negative 3. With an odd index, there's just one solution. So let's do an example of a odd index with a negative number to see. So the third root of negative 8. You want to just try it for fun? Let's see what this comes out to. So let's see, bring out that last entry. To make sure it raises negative 8 to that power, I have to put it in parentheses with the negative. Okay, so negative 8, the third root of negative 8, remember the 1/3, that means the same as this third root, and hit enter. That's negative 2. Okay, and the reason it's negative 2 is because, well, let's see. What number multiplied by itself 3 times will give you negative 8? Well, let's try this. Remember that negative 2 times negative 2 times negative 2, well, if you multiply those together, those two will give you positive 4. Positive 4 times negative 2 will give you negative 8. So that does equal negative 8. So because you have an odd number of numbers, it will keep the sign of whatever's inside there. So if you have an odd index, there's no plus or minus. It just keeps the sign of whatever number is in there. Okay, there's one other thing I want to talk about here. That's if we have variables. If we have variables. So mind the green line there. Variables. And I'm going to go back to this idea of this fractional exponent, okay? So with variables, divide the exponent by the index. Divide exponent by the index. Okay, so it's like we're taking the number and we're dividing it by whatever the index is there. So you can see that's what I did over there, and in the calculator that worked. So hopefully that maybe it doesn't make sense to you, but at the very least you believe it. So let's try a couple of problems here. Let's try the square root of 16x to the 8th power. Now we can't just plug this into our calculator. The calculator would put some number for x, just find the square root of that number. So to do this, take the square root of 16, well that's 4. And then divide the exponent by the index. Divide 8 by, well there's no number there, by 2. So 8 divided by 2 is 4. So the square root of 16x to the 8th is 4x to the 4th power. And even though your TI-83 won't do that, you can always double check those on Wolfram Alpha. It's very good at these kinds of algebraic things. Let's try one more. Let's try the 4th root of a to the 8th, b to the 12th. Okay, and that's a different problem. Maybe I should put a little squiggly line. This will be the last thing we do here. Okay, well again, we're going to take the exponent and divide it by the index. The exponent divided by the index. They both go evenly, and I've set them up that way. We'll have ones that don't divide evenly a little bit later. So 8 divided by 4 is 2, and 12 divided by 4 is 3. Okay, now there's one thing I need to note here. Anytime you take a number to an even power, it always comes out positive. Okay, so if I take, oh, I don't know, what's an even, oh my goodness, look at that, 2 plus 712, that was, please, thank you, clear that out. So let's say you have x to the 2nd power, x to the 4th power, let's do one more, x to the 6th power. Anytime you have an even power, and if you look at the table, those numbers are always going to come out positive. Okay, if you have an even power, they're always going to come out positive. Let's see where that's going to create a problem for us here. This is an even power, but it's still an even power. So this is always positive and that's always positive. That's okay. This is an even power and that's an even power, so that's okay. That'll always still be positive. This is an even power, but it becomes an odd power. So for me to say that this is the same as this, you know, if we look at an odd power, let's just throw one in there. Whoops, I didn't want to do that. I promise. We just put it right there. If we look at an odd power isn't always even. It changes with the sign that it started with. So if I want to say that this means the same as this, I have to add absolute value here. Now this is the same as this. So basically, what you need to remember is that when you go from an even power to an odd power, include absolute values. And that's important enough, I'll note it here. If you go from an even power to an odd power, use absolute value. If you go from an even power to an odd power, use absolute value. And that's it for your notes for section 6.1.